So this is the global coordinate frame. And you can see also two other frames. One is positioned on the endpoint of the robot here, and the other one is the coordinate frame of the tool. So if I've moved the robot, you can see that the endpoint coordinate frame moves, and also of course the tool coordinate frame moves because it is attached on the endpoint. So between the endpoint coordinate frame of the robot and the tool coordinate frame, there is a fixed transformation, so fixed position, fixed orientation, because the tool of course is rigid. So these are the coordinate frames. I will now teach you how to move the robot. So first you will move the robot with the jog joint, and with that you can move each of the joints. So I will first move the first joint. So this is the first joint, the second joint, the third joint. This is the fourth joint. Here is the fifth, and last is this one, the last segment, and this is the sixth joint. We call that internal coordinates because they are defined by the internal kinematics of the robot, so by the structure of the robot. We call also that joint space, so internal space or joint space. And there is of course an external space which is related to the coordinates frames. So this is the global coordinate frame, and we can move the robot in the external coordinate frame. So I will just grab the tool, and now I will move the robot by moving the tool in external coordinate frame. So this is the movement in reference to the global. You can see that the arrows are in parallel to the global coordinate frame. Of course, I can also choose the local coordinate frame. And this is the frame that is attached to the coordinate frame of the tool. So if I move in the local coordinate frame in z positive direction, you can see that the robot moves downwards. But if I choose global coordinate frame, the robot will move upwards because the z direction of the global coordinate frame is pointing upwards. So the local coordinate frame is pointing downwards, but the global coordinate frame is pointing upwards. So this is the difference between the global and local coordinate frame. And you will create also the coordinate frame which will be attached to our object, to aluminum block. And this will be, of course, local coordinate frame of the work object. So these are the main ways how you can move the robots. So joint space and external space. And when you will program the robot, you will also be able to use move instructions related to both space. So one will be move joint, so in joint space, and the other will be in the external frame, so move linear. I will explain that more in detail when we will come to the writing of the program. For now, you have to understand the difference between the global coordinate frame and of the local coordinate frame. If you go to home and pets and targets, all these frames are of course saved inside these station elements. The global coordinate frame is not named global coordinate frame, but it is called work object 0. And the tool data, of course, the tool is saved in tool data. So this is the my new tool, and you can also see that there is another tool called tool 0, and this is actually the end point of the robot. So this coordinate frame is attached to the last segment of the robot, and these are all local coordinate frame, and this is the global coordinate frame. Next, we will continue with adding additional elements into the robot cell. So you go to the modeling, import geometry, browse for geometry, and we will add a model of the table. So the model of the table is called misa.sat. We will add it here. And you can see that also the table has its own coordinate frame. And when you add a model, the coordinate frame of the model is positioned to the global coordinate frame. So if we go to the home, pets and targets, and we click on the global coordinate frame, you can see that this is positioned exactly in the same position. So I'll go back to modeling and choose MISA, and you can see that it's positioned here. And this is also the reason why the tool, when we added the model of the tool, was positioned inside of the robot. So every 3D model of the object that will be added inside of the robot station will first be positioned in such a way that the local coordinate frame of the object will be positioned to the global coordinate frame. Now we will move the table. So first you can move the table. I will move it down. And you can also rotate. And here we will see the difference between the global coordinate frame and the local coordinate frame. So the rotation in the global and rotation in the local. First, I will rotate the table in global coordinate frame. You can see that the table rotates around the z-axis of the global coordinate frame. If I choose local, the table rotates around its own z-axis. So this is how you can move the objects. So the first two icons are related to movements of the objects, and the next icons are for the movements of the robot. You can also input the actual values of the objects. I will show you now how to do that. So you go to modeling, you choose modeling tab, you click on the object and then right click it, go to position and click on set position. And here I will write the values from the written instructions. Press apply and close. Next, I will add the model of the aluminum block. Open. So this will be the model. This is the model of the actual aluminum block that we have in the lab. And this will be also the work object. So you will define paths in relation to that object. So now we, of course, have to move it to the table. So again, right click, position, set position. And now we will input the position. And press apply. Okay. Of course, you can also move by clicking on the freehand icons. I will slightly move it, and I will slightly rotate it around Y axis. Okay. So now we have added all the objects, and we will be able to continue with the definition of the work object.